All right, sorry I couldn't be there again today, guys. You're going to get started right away at page 268. This should take you about, I don't know, 15 minutes only. So get started on that right now, and you can, after you're done, you can check your answers with your group mates, whatever, and then I'll talk about something afterwards. So 15 minutes, get to work, and you can put me on pause right now. Get to work. So two key questions. What's the special name for the solution to the equation? 2x equals a million. And what does log base 2 of 8 mean? You were introduced to logs last year and integrated 2 in the Alice unit. Um, if my experience is indicative, then you guys probably have no idea really what logs are. And I promise we're going to talk a lot about them when I get back, which I will be back on Monday. Um, The simple answer is it's just a way to rewrite an exponential function. So if you have a to the c equals b, you can rewrite it as log base a of b equals c. So essentially we're getting the exponent by itself. Why we choose to rewrite something that seems simple to something that seems much more complex is something I promise we'll talk about. What that means though is if I just had 2 to the third power equals 8, which we know is true, I could rewrite that as log base 2 of 8 equals 3. Again, getting that exponent by itself. So to answer that first question, the special name for the solution to the equation, that's just log base 2 of a million. So it's again, just asking us 2 to what power gets me a million, or log base 2 of a million. So I feel like many of you are probably still pretty confused because logs are pretty abstract and tough to handle, but hopefully a little bit better. So let's move on to 269 and 270. Some of this is a review. It is not new stuff at all. Reviewing from last year. I feel like this will take you about half an hour to do. Um, there's really nothing I feel like I need to say. Get to work on that now. Go ahead and pause me. All right, our last activity is a really important one where we're actually getting derivatives of exponential functions. So we started this unit talking about derivatives, then we talked about exponential functions. Now we're going to combine them. This is super important activity. Remember this for your portfolios. We have lots of ways to get derivatives. Remember, it's just essentially getting our average rate for two really close together points. On your test, I asked you to write a bunch of ways to do it. Our most recent way of talking about it was this, that you have your f of x plus some really small number minus your original function over that h. If you want to use a different formula, by all means, go ahead and use that. If you have no idea, then go ahead and use this and figure out like what is the derivative of 2 to the x when, say, x is 0, when x is 1, when x is 2. I'm going to ask you guys to work on this, and you're going to pause me in a second. I do have what a filled-in table might look like. I really want you guys to try to figure it out on your own, though. So work on it for about 15 minutes on your own, 20 minutes on your own. If you're still stuck, you can ask the substitute to unpause me, or one of you guys can unpause me if there's like consensus. Don't just be that one jerk. I know there's like 7 of you in there just going to walk up right away and want to hit play. Get to work, try to figure this out on your own, and then I'll show you in like 15 minutes. All right, pause me now. All right, so here is possibly what it should look like. So if this is what you had, you're doing great. Um, you really want to see a pattern here. And I think if you look at your derivatives, my hope is that you will see this pattern. And if you do not, we will talk about it on Monday. Um, but yeah, go ahead and get back to work on 10 to the x and then one of your choice. So you go ahead and pause me again now. Oh, that was all I had. Done. See you guys Monday.